I'll be talking about some improvements we made to the Vulkan buffer and image copies in Turnip. These are the Vulkan commands we'll be talking about. These are all transfer commands which do a buffer to buffer, buffer to image to image, image to buffer copy. Internally, we use the A2D hardware to implement these, although we do have to fall back to the 3D path in some cases. With the A2D, we can accomplish these much faster without bogging down the entire 3D path. These are the cases in which we had to fall back to the 3D path, so sample count being greater than 1, which is not supported by the A2D, or an issue with canonicalization where copies were not bit exact. Let's look at what an A2D transfer looks like in the command stream. We set up the register configuring the transfer. We set up the source and destination of the transfer, set up the color format, tile mode, swap, whether it's compressed or not, and we set up the source and destination regions. In this case, the coordinates are the same. And finally, we execute the transfer. The first improvement I want to talk about is the half precision bit for float 16 formats. Previously, we had to resort to the 3D path because the copies were not bit exact. There was a canonicalization issue. We figured out what this bit was doing, and setting this bit resulted in those copies being bit exact. Using the 2D path instead of the 3D should result in an improvement, but how much exactly are we talking about? I had created a benchmark originally for the raw copy changes, which does an image-to-image copy, totaling to 1 megabyte or 16 gigabyte in various chunk sizes. All the benchmarks were done on A750 and generally on Linux. As you can see from the top graph, there's an improvement slightly above 50% in GPU time. So using the 2D path instead of the 3D path makes a huge difference. So let's talk about raw copy now. With A750, new functionality was added into the A2D. We can make use of this functionality by setting the copy bit, the raw copy bit, using the int internal format and the uint color format in the setup registers. This is what the differences look like in the command stream. And let's see some benchmark results now. So that's an improvement of above 80%. Can this be real? Yeah, there was something wrong. There was an implementation error. Sometimes we have to use a staging copy. So this is for cases like the formats being swapped. So where the hardware swap doesn't match, or the color format doesn't match between the tiled and the linear version of the format. So the implementation was incorrect, so the results were invalid. Fixes were made. How did these affect the results? There's some improvement, but not as drastic as we thought. These results are collected on Android. If you haven't gotten tired of looking at graphs yet, here's a table. These are the GPU times for Mesa main for a buffer to image benchmark I implemented to investigate something. The results from the image to image benchmark were showing unexpected results. For the 16 gigabyte transfer, somehow an increasing chunk size also resulted in increased GPU time. For the 1 megabyte one, as expected, the GPU time went down as the chunk size increased. So I created the buffer to image benchmark to see the performance for linear to tiled. The trend was present there too. I believe it's not present in the buffer to buffer copies. So something's up, but the mystery still hasn't been solved. For completeness, here are the results of the benchmark. We can see a maximum of about 25% improvement in GPU time. In closing, here are some other things to look into. So, of course, the first thing is to figure out why the chunk size increase also resulted in GPU time increase for the 16 gigabyte transfer, and then why didn't raw copy help across the board for all formats? It seems like only certain chunk sizes and certain formats benefit from it. Then we could use the raw copy stuff for the def stencil and also in place compression and decompression. We saw the overhead of doing the staging copy, which is quite a lot. So maybe this can help with transfers where the source and destination are compressed.